In this lesson, we're going to take a look at more linear models known as story graphs. We're going to be able to graph and utilize these linear models as story graphs. Real-life situations as linear models are sometimes referred to as a story graph. As you can see here, we have 3 examples of some story graphs, and you can see that they are linear, but they do have some breaks. The places where the rate of change changes indicates a change of an event. When you interpret a story graph, you need to pay attention to the title of the story, the title of the graph. It gives you an indication of the situation. You need to make sure you look at the labels of the axes and what they indicate. You need to see the units, such as hours and inches. You also need to take a look at the scale. On the X and Y axis, these are each going up by 1. That is not always the case. You also need to make sure you look at the shape of the graph. For this course, we will basically look at linear story graphs, but you could have some that have curves. Let's use this story graph to answer our questions. Here we have a snowstorm, and over given time, specifically hours, the amount of snow piled up. Or in some cases, it decreased. So we're going to be looking from hours 0 to 10 during a snowstorm, how much snow was accumulated, or how much snow melted. So let's go through each of the intervals and determine the rate of change of how much snow fell or accumulated. So between hours of 0 and 2, over the first 2 hours, the snow increased 1, 2, 3 inches over 2 hours. So this first section of our story graph, it accumulated 3 inches over 2 hours, which is 1.5 inches per hour. Between hours 2 and 4, there was no additional accumulation. So our rate of change of a snow is 0. It was 0 inches over those 2 hours that accumulated. Between hours 4 and 8, we can see the snow accumulation decreased. So apparently the sun came out and made the snow accumulation decrease. So over 1, 2, 3, 4 hours, the snow went down 1, 2, 3 inches. So this had a constant rate of change of negative 3/4 or negative 0.75 inches per hour. Then our last interval between hours 8 and 10, the snow accumulated 1 inch. So 1 inch for every 2 hours, which is the same as 0.5 inches per hour that accumulated. Now let's answer our questions. Between which 2 intervals did the snow accumulate the most because it fell the fastest? So we're looking for our rate of change, a positive rate because it's increasing. And that would be between hours 0 and 2. So this part of the story graph has the steepest slope of accumulation. So between hours 0 and 2. Between which interval did the snow melt? That would be here from 4 to 8. The snow melted because it decreased. Between which interval did the snow not fall at all? That would be between hours 2 and 4. We had a change of 0. And then the interval of where the snow fell the slowest would be between hour 8 and 10. we have a rate of change of 0.5. Here we can create some stories given a graph. We don't have any specific numbers. We need to look, so we're looking to see what happened as time goes by, what is happening when you are the distance from home. So we're starting here and we must be moving away from home because this represents the distance from home. So here we can see that we are at a constant speed going away from home. Then it looks like we take a break and then we pick back up with the same speed that we started with. So section 1 and section 3, we can label these, looks like they have the same rate. So we ran from our house, we took a break, and then we picked up with our same speed. You can have a different story. Keeping with that same situation, we can see that here we started at home, we ran, we took a break, and then we maybe walked further away from home because this has a smaller slope, a lower constant rate of change. In our third example, we are starting away from home and we are coming toward home. So let's say we are running home, we take a break, and then we pick up with the same speed and continue until we get to our house. In our fourth example, we can see that we're looking at temperature now and time. So we can see as time goes by, the temperature increases, then it stays the same temperature for a while, and then it starts to increase again at the same rate as it did in interval 1. Here we have time and temperature. So this time it gets hot real quickly, then it stays that temperature, and then the temperature increases, but at a slower rate than it did in interval 1. Here we start out with a hot temperature and it decreases, then it stays the same, and then it continues to decrease at the same rate as it did in interval 1. So again, here are just some story graphs where we have a change and we have several different sequences in our graph. But you notice each interval is still linear. Now you come up with a detailed story for this given graph here where you can make your x-axis anything you want, and typically it's usually time. It could be hours, minutes, weeks, years, and then you can make whatever you want for your y-axis to be. And then just notice that we have a decrease, an increase, a resting, and then a gradual increase.